Section 6.6, division of polynomials. Here in this example, we have a function f over g of x. If you recall, this notation is equivalent to asking us to divide the function f of x by g of x for a translation. If we use a substitution, f of x is defined as this polynomial. G of x is given as this binomial, and when we're dividing by a polynomial, similar to long division, we will take our divisor and divide it into our numerator. We want decreasing powers of our variable. If we're missing a power, we would put a placeholder or space. We have 9x squared, 9 to the first power, and then our constant term. So they are in the correct decreasing order, and there is no missing power, 2, 1, x to the 0, or our constant term. So we're ready to do our division. We take our highest power term in our divisor, determine what we would multiply it by, in this case 3x, to give us this leading term here. To get 3 up to a 9, we need to multiply by 3, and to get our x to an x squared, we would need an x. 3x times 3x is 9x squared. Think of this as distributive. Not only do we multiply the first term, but every term of our divisor. So -1 times 3x is -3x. We're subtracting, but we're subtracting a quantity. And using our rule of subtraction, which is a minus b is the same as a plus a negative b, is a good approach to avoid any errors. Most of us will remember 9x squared minus 9x squared, but we may forget to come out and also recognize we're subtracting a -3x. To avoid that from happening, best bet is to use this rule of subtraction, which says if you're subtracting a quantity, change the signs to the opposite. So our 9x squared becomes a minus, our minus becomes a plus, and now we're ready to add. The rule of subtraction is applied here. 9x squared plus a -9x squared is gone. Your leading term should be gone. And then we have a 6x plus 3x gives us 9x. We're ready to bring down the next term and go back to determine what we need to multiply our highest term in our divisor by. 3x times what gives us 9x. We would need just a 3 because we already have the x. Distributively, 3 times 3x is 9x. 3 times -1 is a -3. And if you already guessed, these are going to cancel out. In other words, it goes in evenly. But again, just to illustrate the subtraction of a quantity, I'm not only subtracting this, but I'm also subtracting this second quantity. Using the rule of subtraction, my 9x becomes a minus, my minus becomes a plus. I'm now ready to add. These are opposite terms, these are opposite, meaning there is no remainder. Our answer then to finding f over g of x is 3x plus 3, the quotient. This problem also asks us for the domain. With the division, problems on domain restrictions occur when our variable's in the denominator or underneath a radical. Well, there's no radical, but we definitely have a variable in the denominator with this division. So to answer the second part on our domain, we never want to divide by 0, which it means 3x minus 1 cannot equal 0. And what value will cause that to equal 0? Well, let's solve for x. Add a 1 to both sides, leaves a 3x. And I'll continue to put the not equal to a 1. Undo multiplication with division. We would get a 0 if x was 1/3, and you can see 3 times 1/3 would give us a 1, minus 1 would give us a 0, which is undefined in the math world and cause all kinds of problems. So our solution is 3x plus 3, provided x is not equal to 1/3. So our domain for this problem would be all real numbers with that exception.